So my research, I'm going to talk about the research in my lab. My lab, the name of my lab is Intelligent Systems Lab, and the research in this lab focuses on human-centered AI by developing computer vision and machine learning algorithm to estimate human state, to augment humans' ability, and to allow natural human and machine interactions. So we focus on developing computer vision and machine learning algorithm in order to improve humans' capabilities and to have natural human machine interaction. So now let's in computer vision, our research have two main areas. One is the automatic facial behavior analysis and recognition. The second area is the body behavior analysis and recognition. So first, let me talk about the facial behavior analysis and recognition. So the first task for facial behavior analysis is automatic detection and tracking faces at different face angle, face orientation, facial expression, and for different people. So here in this image, you see that this is the result of face detection for different human subjects for over different face direction, face orientation, and facial expression. So second task is the facial landmark detection. So here we want to detect some important landmark points on the face, and these landmark points are important to capture the facial expression, and also can be used subsequently for height pose estimation. So we need to automatically detect these landmark points for different subject, for multiple people under different face orientations, with occlusion, with different type of occlusion, right? So this is remain a very challenging task. So this is the second task for facial behavior analysis. Next is the facial expression recognition. Once we have the facial landmark points, then we can perform facial expression recognition. And we are interested in actually perform two types of facial expression. One is what we call the global facial expression. Here we want to recognize the overall facial expression, for example, surprise, happy, sadness. So this is capture the overall facial expression. We are also interested in the local facial action recognition. Here we want to recognize the facial motion near a facial component. For example, here is the facial action near the mouth corner, and this is the facial action near the cheek, and here is the eyebrow. So this is very important. These local facial action are very important in capture the real emotion of a person. So this is facial expression recognition. And then another important area in my group is eye tracking. Basically, we want to estimate the eye gaze. Eye gaze is the line of sight of a person, right? We want to know where the person is looking at. And over the years, we have developed different eye tracking technique. For example, we are able to do eye tracking for desktop-based eye tracking. Basically, we are people sitting in front of a console, then we are able to estimate where a person is look on the screen. So this is the desktop-based eye tracking. Then we are also began to work on eye tracking on a smart phone on the handheld device, right? So this is basically once you are looking at the screen of a mobile phone, we're able to tell which part of the phone that you are looking at. And then we are also interested in the long-range eye gaze tracking. And here, basically, we want to know where you are looking at from in the long range, far away from looking at the object far away from the subject. So we are developing computer vision techniques for these different type of eye gaze tracking scenarios. And so this basically is about facial behavior analysis. Next is the body behavior detection and tracking. So the first thing we do for body detection and for body behavior analysis is the body detection, right? We have developed different techniques that detect the bounding box. Within the bounding box, we can have the human body, and we can also detect the silhouette, right? So the silhouette contains the human, and then we can also detect the body joint angles, joints, right? And use these joints to measure, to capture the human body. And we not only can do detection for each image, we can also do body detection tracking in real time over video, in real time on videos. So this first step is body detection and tracking. Next is the body gesture recognition. Once we have the body, detect the body, then the second task is we want to recognize different body gestures, right? And here we focus on the upper body gesture. This is the different type of upper body gesture that we can recognize. So this is the second task we have been working on. Next is the human action and activity recognition, right? Here we are interested in the human action. So maybe, for example, there's an interaction between the two people, right? Interaction between two people. We want to know what kind of action. For example, this may be the shaking hand. This may be a dialogue. So we want to recognize this interaction between a human. We are also interested in human activity recognition. For example, we want to recognize what is the activity a human is performing in the parking lot. For example, here it involves getting into the vehicle, get out of the vehicle. So specific interaction between the human and the vehicle. So this is also something that we're interested in recognizing. So this basically is about human body behavior analysis and recognition. So now I want to talk about the machine learning research in my group. So the machine learning research in my group focuses on 3 areas. The first area is the probabilistic graphic models. The second area is deep learning. And finally, we are also working on causal learning and discovery. So first, I'll talk the probabilistic graphic model. Basically, we were interested in develop this graph. This is a graph is a probabilistic graph. It captures the joint probability distribution of random variables. And with this graph, we'll be able to perform to capture the concisely and efficiently capture the joint probability distribution, and based on which we can do a lot of inference and recognition. So we have been doing much work in the directed graph. So this is also the Bayesian network or DAG. We also have done work in the undirected graph, right? This is the Markov network. In addition, we have also have done work in the dynamic graph, dynamic network, such as dynamic Bayesian network. And we have also done some work in terms of decision graph. So in this graph, not only it contains random nodes, it also contains actions. So this is the probabilistic graphic model. We focus on developing efficient learning and the inference method for different types of graphic model, and try to scale up the learning of the model to large data set. So then in deep learning, we are focused on several areas. First is the probabilistic learning. So we're interested in develop the deep model that capture the probability distribution of the data. And for example, one area is the Bayesian neural networks. So we're working on the Bayesian neural network. This is a probabilistic version of the traditional deterministic neural network. We are also interested in the probabilistic deep models. So this basically is an extension of the graphic model to the multiple layers, the deep probabilistic graphic models. So for example, we have done some work in deep Boltzmann machine, deep belief network, and deep Bayesian network. So the second area of deep learning is the knowledge augment deep learning. So instead of doing only data-driven deep learning, we are interested in combining data with prior knowledge, because we think the prior knowledge is very important. And this makes the deep learning very data efficient, and also make it generalizable to different new scenario or new data sets.
You got 30 seconds to wrap up.
Almost finished. Okay.
Okay.
Yeah. We also have a structured deep learning. Basically, the structured deep learning is we'll combine deep neural network with graphic models. So this is basically right now for the deep neural network they use a very simple function such as softmax. Here in the front end we have neural network. Rear end we have a graphic model. And finally, we are also interested in the self-supervised deep learning. And here, this is one issue with deep learning is that there are not enough labels. And the self-supervised deep learning allows us to train the deep model with automatically generate labels. So the final area in the machine learning is the causal learning and discovery. This is also very important direction and research area, because most current machine learning is correlation based. Causal learning and discovery is very important. So we have done some work in the local causal network learning. For example, given the target variable, we're able to identify the effects and the causes of this target variables by learning this local causal network. And we are also interested in learning a global local causal network by learning the local causal network for each node, and then put them together to construct this global causal network. In this way, we will be able to do the causal analysis. For example, this is the cause, so we can trace this to be able to identify the cause for this node. And finally, So, in the machine learning computer vision, we have applied them to different applications. This is the last page of my slide. Okay. So this is, for example, for human robot interaction, and for natural human machine interaction. Here you can see this human interact with the screens by using the gesture. We also have applied this to driver behavior analysis to detect a drowsy driver, fatigue driver, and inattention driver. And this has our research has also been used for security, surveillance, biometrics, and this is VR, AR, games. That's all.